Hello all. In this video, we are going to check another test.mnemonic file. We are going to this time in this video we are going to use save mnemonics. This uses file system to save a generated mnemonic into our file, and we are going to use get mnemonics. These are written by us. These are local. These are not given by some package, and then we shall see how our ability to use one fixed seed phrase deterministically gives us one fixed key pair. So moving on, this is the whole code chunk. It's all of 36 lines in total, and out of that much of it is just console logging. The logic is quite simple, so we'll just start exploring. The imports that it uses is mostly the same as what we did in the last two videos about mnemonics or seed trace. Derived path BIP39, and we see get mnemonics and save mnemonics that we are getting from our own folder. They are present right here in the helper folder. So let's look at it. This is a simple fs file. Let's look at save mnemonics first. So let's clean this one up. The only import here is fs, and this simply uses a fs write file sync like we had done for keypair. It takes a file name as a string, it takes a serial number, and it takes a mnemonic that is a seed phrase string. And here it takes the file name. It goes in this one is pointing to the folder mnemonic which we have here. You can already see there are 3 of them that have already generated, and this is how it looks. So I'll close them now. We can look at them later. So mnemonic folder, then we generate the file name from the provided file name, that is a string. We combine it with the serial number, so we have this kind of naming, mnemonic 1, 2, 3, so that we can target each one. And then we get the mnemonic. This mnemonic goes into the file. So this is the file location, file name and file location. This is the actual data that goes in string format, and the encoding is UTF-8. Similarly, get mnemonics does the same with read file sync. It points to the folder, the file name and serial combined to create the file name, and the encoding is UTF-8, and it returns the seed phrase. So this is quite simple. For now, I'll close them. Here in our test mnemonics file, we first generate a mnemonic here. I'm sorry, let me get, we first generate a mnemonic here, and then we do a save mnemonic. We provide the name, we provide the serial. Serial is 3 here because the last time I did it was 3, and this was the file that was generated. So this time when we are running, let's generate a new one. Let's do 4 here, and in the next line we are doing const stored mnemonic get mnemonic. This gets the mnemonic 2. So let's set this to 4 as well, so that it after the mnemonic has been saved, it manages to get, and then we can see how we can deterministically get the keys. Now there are a bunch of commented lines. We shall look at them later. This one, seed phrase, is equals to stored mnemonic, so it points to the mnemonic or the seed phrase that we got from our file system. We could change this to 1, 2, 3 or 4, and we shall get the one that we expect to get. Here is the path. In this video we shall change this value and see how it changes the seed phrase. Then the same old usual mnemonic to seed sync. This takes the seed phrase, creates the byte, and so on like we did in the last video. Here seed gets converted to a hex string. Then we get the key out of the derived seed, and we give it to the keypair.fromSeed method. And here let's see what all we are console logging. Let's console log the generate let's console log generate. Let's see what generate is. Generate is the new mnemonic or the seed phrase that we just generated while running this code. Here is seed phrase. Seed phrase is the same, happens to be the same because we saved this, the mnemonic 4. We will be saving the mnemonic 4 and then we'll be getting the mnemonic 4. But if we change this, then this seed phrase is going to change, and we shall see that soon. So in case the value that we have in serial for save and the value we have for get mnemonics are different, generate and seed phrase are going to be different. For this case, this time when we run, they are going to be the same. The next line, seed, we are just console logging seed to string. Let's see what seed is here. Seed is the byte code, the byte conversion of seed phrase, and seed phrase is the seed phrase that we are getting using our get mnemonic method, and that is converted to hex. Next we are console logging derived seed. And what is derived seed? It is the it uses the derived path, same old path, seed to string hex. And we shall probably see, we know what we'll see. We'll see a hex value which has a key and a chain code, but we'll be using only the key. So the next line is derived seed key. So here derived seed dot key. So we could just like we saw in the last video, we could get rid of this line 30, but we'll just have it just for the sake of learning. And then the next line is the key pair that we generate from derived seed key. So here we have written the function, here we call the function, and we shall run this file right now. I'll clear the CLI, I will increase the size a little bit, and here yarn ts node help us ts mnemonics.ts and run, taking its time. Yeah, so here is a key pair, and let's scroll up. Here is what we generated, and we know that after we generated, we saved it to a new file, and the new file has been created. Here this happens to be that we see much real favorite, and that is what has been console logged here. This is the one that is generated. Then this gets saved to this file, and seed phrase uses get to fetch the file from fetch the phrases from this particular file, and then that is converted into bytes. We see the byte representation, and then we see the derived seeds. It has a key object and a chain code. We don't use the chain code, so we get the key from it. This is 27cc f5, 27cc f5. This is the key, and this key is used to generate this key pair, like we saw in the last video. Now let's see how deterministic this code is. So I'll just minimize this. Now that we have generated 4 of them, I'll just comment this line, and we'll just use our own number here to get the mnemonic that we wish to. Let's get this mnemonic here, this beef, scorpion, lobster mnemonic, and here we are still generating, and we are console logging the generated mnemonic. So when we console log generate and we console log stored mnemonic this time, this is going to appear different. This is going to be a randomly generated mnemonic, while this is going to be our own beef, scorpion, lobster. And the key pair that is going to be generated is going to be from this mnemonic, and we shall run this code 2 times, and we shall see the generate change 2 of the times, but the store mnemonic does not change, and hence the key pair does not change. Let's do that. I'll run this one. Let's make sure I save this, Control S. Now I run this, the same code. Yeah, so let's see. You see here the generate is pledge gorilla feature and the seed phrase is beef scorpion lobster. And let's look at the key pair. The key pair is the public key is 114140. The secret key starts with 154153 and it ends with 223 just like the public key. Now let's run it again and let's expect that the secret key starts with 154 and 223 because the seed phrase we are getting is this, which is our own, and hence it should deterministically provide this same key pair. And it does, starts with 154, ends with 223. Now the word deterministic here means that as long as the input provided to this method is the same, that is, as long as the seed phrase provided to it is the same, it's going to generate the same key pair, which is essential when we need to generate the key pair for our wallets because we might have funds. So if it does not generate the same secret key or the same key pair, we basically lose that, and hence that is the use of seed phrases. Now let's do one more thing. I said deterministically and as long as we provide the same input, but here the derive path method that provides us the key that is then used to generate the key pair takes two inputs. It takes path and it takes this seed. So the seed here is going to be constant, but let's just change this value. Now we have changed the value to 44501 M44-501-0-1-. It was not the same. So now the input that we are providing has changed. Let's see if the key pair generated remains the same. Console log the same code again. Let's scroll up first. Let's see. The seed phrase is beef, scorpion, lobster, which is our mnemonic, nothing new. And the generate is different as we know, but we are using the seed phrase to generate the key pair. So what happens? It's a different seed phrase, as you can see, a different key pair. And that happens because we change the input, one of the input, that is the path. And this time it gives us 5511 and it ends with 245-225. So it has changed. But if we change the path back again to 0, now we have made all the inputs the same as last time. So it uses this mnemonic seed phrase and it uses this path M44-501-0-0-. So let's see what deterministic really means. If the inputs are the same, the output should be the same. Let's see if it gives the older key pair that we were seeing in the last console log, not this, the older one. And yes, that is true, 154, 153, 120, 223. So as long as you give the same inputs, it gives you the same output. Let's do it for mnemonic 2. Let's look at mnemonic 2 here. Mnemonic 2 is daring donkey sponsor. So we'll run, it's going to generate a new one. Generate is going to be different. Let's see. But it is the seed phrase that is going to look at is going to be daring donkey sponsor and so on. Let's look. Yeah, the seed phrase is daring donkey sponsor, and let's see. Its secret key is 195.16.211.230. Let's change the path. Let's change the path to from 0 dash to 3 dash. As long as you change it to anything different, it's going to completely change the key pair and there is going to be no similarity whatsoever to the older one. And once you come back, let's go back to the older one. Let's go here, let's do a Control Z, save it, and this again, let's run the same code again, and we see 195.16.211.230. Let's scroll up. This is the one with the path 3 dash. Let's go up. This one is the one, okay, little bit, yeah. So it is this path with 0 dash at the end, 195.16 to 11230. As long as the inputs are the same, the seed phrase and the path, the output is going to be the same. So that's it for this video. In the following video, we are going to understand how transactions work and what is displayed in the Solana Explorer when we conduct a transaction. Thank you.